Hello, in this set of videos, what we will be doing is taking a look at linear regression and doing it via a case study in Python. The purpose of this session is both to review some of the conceptual ideas in linear regression to see how they can be executed inside Python, and also to be able to review some other ideas in data pre-processing and data analysis that are relevant to any analysis that we might do in Python. So some of the things that we will see in this video are particular to linear regression. Some other things are relevant to data analysis and Python coding in general, and we might skip over some of those areas. You are welcome to look at other content to refresh the ideas in data pre-processing and analysis, as well as Python, in case you run into some difficulties on those lines while seeing this video. To begin with, let us set a context. And the context is a context of sales. Businesses need to optimize their sales. And one way to do that is to be able to understand sales in terms of other variables. The dataset that we're going to look at is a dataset that concerns sales of a device, and you can think of that as mobile phones or tablet computers. And what we will do is we will look at sales as an output variable or a response variable, as people say in linear regression. And we will look at a series of variables that will help us model or predict sales. So, as we go through the notebook, you will see certain cells that are comment cells, that essentially are markdown text. They describe what is happening in the following code, but they are not pieces of code themselves. For example, what you see here are the objectives of the analysis. And it says that as a data scientist, you are provided with sales data from the recent past, along with other attributes dealing with pricing, promotions, customer engagement, etc. The word attribute is used in a business setting. These are things that influence sales. From the perspective of modeling, from the perspective of supervised learning or regression analysis, these will be our predictor variables. So the way this will work is a dataset will be loaded. But before we load the dataset, let's get a sense of what we expect the dataset to be. One way to state that and to make that precise before we do the analysis is by clearly defining a data dictionary. A data dictionary essentially serves the purpose of telling the analyst that when a data set is loaded, what will it contain or what should one expect it to contain. One of the styles that data analysts often use is to keep the response variable as the last variable, or the column on the right, if you want to think of it that way. So in this case, the 10th variable that we're going to look at, the last element of the data dictionary, is sales, which is the amount of sales in dollars. This is going to be the main variable that we are trying to predict. This is the output of our regression. The other variables that come before it are input variables. They are variables that are used in order to predict or model sales. They will be on the X side of the equation. The Y variable is a sales variable. We will have to find a way of specifying this. In other words, what is the X and what is the Y? And we will get to that problem here. Product, of course, if you want to fix it in your mind, is, as I said, a mobile device, a telephone device, or a tablet PC. And you can think of any other product that would fit into a similar kind of scenario. For this notebook, the code is already visible to you, and it will be visible as we go through this analysis. We will run the code and we'll see what the output is. But as you visualize the code in the sense of see what the various lines are, you should get a sense of what the Python code is trying to do. Usually what we do is we try to import the libraries that are going to be helpful in doing the analysis. We may not succeed in this all the time because there may be a library and there may be a function that we might need in the course of the analysis. And we can import it at that time as well. So if you don't get this right, not to worry. We can, as needed, always import. But for now, what we are identifying is what we need to do in order to run what we have. You will see these libraries in action. But just to explain the broad context of them, pandas and numpy you have seen are things that Python rests on. Numpy is a calculator and pandas is a way to input and work with data. We'll also be looking at plots, visualizations, and pyplot and seaborn are ways to do that. Then comes, shall we say, the libraries within which the linear regression is hosted, so to speak, where the code is. There are many. What we will be using for this demonstration is sklearn. Now, sklearn is a standard machine learning library. Many algorithms are present within it. From it, we will be picking up certain methods that we will use. Again, let me very briefly try to give you a context for that. The first from sklearn.model selection is to import train_test_split. Why are we doing this and why will we do this? Because what we need to do is to build a model on a certain data set and to test it on another data set. So this mechanism allows us to take data sets and split it into test and train. Train is what we will build our model on. Test is where we will see whether it worked or not. What is the model itself? Again, sklearn gives you many choices. And within linear model is what we will really use, linear regression. This is the set of methods that will help generate the fits and the coefficients and everything that we need to do that. Once this model has been built on the training set, it will now need to be tested out, so to speak, using evaluation metrics. Evaluation metrics such as mean absolute error, mean squared error, the R-square metric that is used by statisticians, etc. And what we will do is apply these criteria. As you can see, as I hover my mouse, you can see what these functions and what these libraries are capable of doing. And you're welcome to try this out if you get a notebook of this kind. So now when we run this, and I'm going to go here to run cell. And when we run this, while there is no output expected, but this has run, and now all these libraries are available to me. The next step that I'm going to do is to load the data. Now, there are various ways in which data can be loaded. The easiest way to load data is to load it from the same, shall we say, repository or directory within which the code is there. That could be, for example, a drive. What do I mean by a drive? A drive essentially is the set of folders that you are using to do the analysis. We are not going to load from a drive, but you typically will load from a drive when you do this. We have already done that work for you. So we don't necessarily need to do this, in other words, to be able to load or mount a drive. But it's there in case you want to see how such data sets normally get loaded and then are accessible to the notebook. Since in my case, this is already loaded, what I can do is I can now say that I'm going to read this CSV file. I'm not going to show you the CSV file, but we're going to load it and then we're going to see what it looks like. How? Pandas read.csv, and I'm going to call that sales. So now that has run. Once that has run, I can now work with it. Work with it means doing different things on the data set. This is risky. This is risky because I've loaded what I want to think of as the master data for the analysis. And so I'll be doing different kinds of manipulations with it. So one practice might be to say, once you've loaded, shall we say, the raw data, keep it available to the code, but don't manipulate it. Don't change the raw data. One safe way of doing that is to create a copy of it. And that is what this is doing. In other words, what it's doing is it's saying, okay, my working data for the analysis that I'm going to do is going to be in something that I'm calling data. Just that. It's simple. It's not characteristic of what my output is, but I now know that my sales object is still available for me in case I want to do a different kind of analysis.